Alright, so for question 8.9-19, it says draw Mohr's strain circle for the following plane strain state. So strain X is 90 micro, and strain Y is 270 micro, and strain 1 is in the principal strain plane is 330 micro, and determine the following the shear strain principal, the second one, right? E minimum, which is strain minimum, and the angle, that rotation, right, to shift that into the plane state, principal plane. Okay, so let's see. Start with a XY coordinates, and then we can. What happened to my? Okay, right here. So maybe use red, yellow. Sorry, this is the strain coordinate, and then this is the shear strain coordinate. Okay, so it says there's 90. So let's say they have a common factor of what? I don't know, maybe 90 or 30. So 1, 2, 3. Okay, so the X is from here, and then you go up by how much we do not know. Okay, we do not know this, so X is somewhere along this lane, right? It's somewhere along. There's no dash line option. Okay, and then there's the 3 and 9, 12, 15, 18, 21, 24, 27. Okay, so and then here's somewhere like Y, right? Y is somewhere here. Okay, and well, we can calculate the minimum or the average real quick. E average equals the sum of strains in X and Y direction divided by 2, which is 360 divided by 2, 180, right? Or macro. Or you can write this, or you can write, I usually just write macro strain. Okay, so which is 6 away from here, so which is right here, this is the average. So it's some right between these two lanes, right? I don't know how the angle would be, but yeah, it's that much. Okay. And let's see, what other information do we have? We have 330, so that's 11, right? If each one was 30, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so and this is E1, right at this point. So remember how we figured out E1? This is just E average plus R, right? So E average is 180 plus what R is, and then this is 330, right? U macro. So what is our simple, subtraction? 20, 10, 30, 150, right? Macro. Okay, so now we know what R is. We can, continue to figure out some other stuff. We can figure out what E2 is, which is already, one thing that we're looking for. Let me just write something on top. So this shear XY equals E2 equals, and the angle equals. Okay, all right, just for clarity. Okay, so E2 equals this, strain 2 equals this, equals the average, which is 180, U minus R, right? So that's going to be 30. So we know that the other one is going to be here. This is where E2 is, right? So E2 is 30 macro strain. Okay, perfect. What else can we try to find? Let's see. So we're going to draw a straight line from here. Let's see what information do we have. So this distance from here is r, right? Is r. We don't know what angle that is. We don't know anything, but we do know the distance from here, which is 330 minus 180, right? So we can calculate the angle pretty easily, and actually the distance over here, which is going to be the shear XY strain, right? So we have the, let's calculate the angle first, just because. So P1 equals half, well this is 2 theta P1, right, this angle. Okay, so it's inverse of tan, because of this 2 theta, so it's 1 over 2 over here, right? Inverse of theta, what is this? We don't know what that is. Okay, you know what, this is, why did I do this? I can just use a different one. Actually, let's calculate the shear strain first. Equals half theta sorry, opposite over adjacent. What is wrong with me? Oh my gosh. Yeah, opposite over adjacent sine of this, or excuse me, erase this. We know the distance over here. Let's see, where's the pen? Okay, so sorry, cosine. Oh my gosh, it's late here. I really need to go to sleep. But yeah, cosine of what is this? Adjacent, which is we just well, is 330 minus 180, right? Over r, right? And r we calculated over here to be 150. Okay, so 2 theta p1, that equals 2 theta p1, right? So 2 theta p1 equals, all right. So this is y, okay? Oh, sorry, yeah, remember, this is y and this is x, right? So we figured out this angle, which is this angle over here, right? These are the same, but in reality, we're trying to find this angle over here, 2 theta p1. Sorry, this is just, I don't know. Yeah, so we're currently figuring out this angle over here, which is this angle over here. So 180 minus that angle, it's going to give us this. Remember, x, either the strain or stress, will always rotate towards this 1, right? Stress or strain 1. Okay, so I don't know, I guess 180 minus 2p1. Okay, we can just do that real quick. It's going to be 63. Well, sorry, it's going to be 1264 degree, and then so theta p1 is 63.4 theta. So we can write 63.4 theta, and cool. So we got that. Now we can just find out what y is. There's so many ways of solving it, right? Let's see, there's the normal trigonometry. We know this distance, which is, 150, right? We know y is also 150, so yeah. Anyway, okay. Let's see. what else can we try to figure it out? Oh yeah, sorry, shear xy. Yeah, there's the normal trigonometry way of doing it. We know two length, two sides of the triangle, and we know the angle. So right angle triangle identity, you can figure this out really easily. Just remember that, you know, xy equals, oh sorry, that's the maximum, but remember to times 2. Remember times 2 once you find the actual one. That's the only difference between the stress and strain Mohr circle differences. Or you can use the, I don't know, I used it in my homework, is using the circle equation. So it's x minus 180 square plus y minus 0 square equals r square, right? So 180, right? That's the center, and then that's where x is, also where y is, right? And then we, you know, we know what r is. Okay, so r is, you know, macro square, right? Y is 0, right? So y square plus, where is this x? So this x is at position, let's see, 270. So it's 270 minus 800 at 180 square. So this is a constant, this is a constant. You have one unknown with one, you know, so this would be, in the end, it should be 120 use strain. Well, it would be negative, right? But you're using the y one, and you know, strain y equals, or sorry, just the y equals strain y and minus, right? Xy over 2. Okay, so this is minus and the minus again, which is positive. So we're positive. And remember times 2, right? Because this is 1 over 2. So this is going to be 240 micro strain. And this is 240 macro strain. Okay, perfect. So yeah, this one. So for you to be able to solve this question, it's sort of just like, you know, first you have to know how to construct a Mohr circle. You have to know the shear stress is divided by 2. You know, there's little things here and there, and then to be able to know the, you know, circle equation. But you don't have to use it. You know, simple trigonometry identity will help you to solve it. And the second part is that the ability to test you as a engineer, the ability to test you as a mathematician, right, is I give you some information, you know, draw out or you know, pull out as much other mathematical information that's related to this, you know, as possible, right? And once you have enough, you know, you have enough information, once enough different equation with the X amount of unknowns, well, then you can solve this problem. You know you can, right? Either you have to use matrices, or, you know, just 2 equations, 2 unknowns, so just simple substitutions. But yeah, just, you know, usually that's what I do. I basically solve this problem while I'm making this video again, right? Because I know there's a way to find it, and I just need to pull out as much mathematical relationship as possible between all these things. And then it worked out. You know, I used this equation doing my homework, but, you know, I also use the trigonometry equation in this video. So yeah, you know, sometimes you discover or rediscover new methods, right? Okay, hopefully this was helpful. Good luck on your studies, and I'll see you in my future videos. Bye.